everybody, and welcome back to Mathematical Misconceptions. And today we're going to look at a very simple system of equations. And we have it set up for us so that we have 7x minus y is equal to 2, and y is equal to 16 minus 2x. And guess what? This is going to make it very easy to substitute. We don't have to rearrange for elimination or anything. We can plug, chug, and go away. However, there's a common mistake that I see with students when they plug in things and it creates a huge error in their answers, and then they wonder why the dots don't connect. And today we're going to address that and show you the technique that I use to make sure that you never make that mistake again. If you're ready, let's dive in. All right, so as we said, we have two equations here. I like to number them as 1 with a circle, 2 with a circle right there. Some teachers do that as well, yours may not, but I always say keep your things organized as much as you can because you want something that you can study so you don't have to do a ton of practice problems. You want process at the end of the day. And what we're going to do here is we recognize that 1 is in a form where it's going to be used to solve for a variable, but number 2 is already in a form that we can just basically plug it into 1. So the way I like to note that is 2 goes into 1. Alrighty, so we're going to talk about the mistake first that I normally see with substituting. So let's go ahead and write this out. So 7x minus 16 minus 2x is equal to 2. If you see the error, just wait. All right, so what do I do here? Let's go ahead and combine like terms. So we have 5x equals, and then add 16 to the other side, 21. And then x is equal to 21 over 5. All right, and then from there, we can just plug this in right here. So in equation 2, we can just plug in our answer. And we have y equals 16 minus 2 times 21 over 5. And then that's just going to give us, let's put 16 over 5. So 5 times 16 is 80 over 5. Minus 42 over 5, which is equal to, and then what is 80 minus 42? That's 38 over 5. All right, so then what we have to do here is we have to plug this in and verify that it works. So let's plug it into equation 1. So our proposed solutions is 21 over 5, comma, 38 over 5. All right, let's try it in equation number 1. So in 1, we can just plug in 7, 21 over 5. That's our x value, minus 38 over 5. And we're going to pray to God that's equal to 2. First thing I would do is I multiply everything by 5. So 7 times 21 minus 38 is equal to 10. Well, I can already tell you, I'm not going to really go any further than this. This is certainly not going to end up being 10 at all, right? I mean, you can multiply it out if you want, sure. So you have 147 minus 38, and that's not 10. So what was the mistake? The mistake I see a lot of times is that when there's what I call binomial substitution, 16 minus 2x is a binomial. A lot of students will forget to put a set of parentheses right here and right here. You have a container right here, right? And your container is defined as y. And so this is y, and this is y. You have to make sure you place your container properly. Everything goes in. And everything is being subtracted. So what does that tell us? That actually tells us that we need to distribute a negative sign through the container in order to operate on it properly. So now we can erase this. We'll try this one more time. All right, so now we distribute the negative through the container. 7x minus 16x, or just 16, plus 2x. So negative and negative make plus. That's where the big mistake is equal to 2. Combine like terms, 7x plus 2x is equal to 9x, is equal to 18. And then x is equal to 2. Like that a lot better. We can see this is clearly wrong too, so I'm just going to go ahead and erase this. If x is 2, then we can plug it into equation 2. Let's just do it up here, keep it nice and simple. Let's just plug it into equation 2. Y equals, and then we have 2 comma something. We'll figure out what that is. 16 minus 2 times 2. 2 times 2 is 4. 16 minus 4 is equal to 12. So the point of intersection of two lines, point of intersection, 212. That's what we look for when we solve a system of equations. There are 3 things that can happen. There's a point of intersection, which is the most common. The 2 lines are parallel, so they never cross, or they are completely overlapped on each other, dressed differently. And you have to use algebraic manipulation to, for sure, to see that Fred is over here and Fred is over here. And that's how you have infinite solutions. If Fred is dressed up one way and his clone Fred is dressed up another way, that's an infinite solutions right there. That's the analogy I love to use. All right, we have a solution 2 comma 12. Now what do? We have to plug it in. We don't need to plug it in here in the second equation. We know that works, right? The real test is in equation 1. So let's go ahead and do that. So for equation 1, we have 7 times 2 minus 12. And is that equal to 2? Well, yes, it does. 14 minus 12 is 2. We are good to go. And that is how you can verify that you have the correct point. Is if you plug it into both equations and it checks out, you can relax. You've got it. Unless you made a really bad algebraic error. Alrighty, so when you're substituting, again, remember, you got to think of it as a container. You got to throw the entire container in there. So make sure you do that as well. This is mathematical misconceptions with substitution, namely in systems of equations, but this applies to a lot of other things. So don't think that this is going to stop here at systems of equations. This is going to follow you throughout your algebraic journey into Calculus BC and even beyond if you pursue engineering or science. If you have any questions, please drop a comment below. I would love to address it with you. Otherwise, I'll see you in the next video. Thank you.